That little activity you used to do in kindergarten where you'd take a blank piece of paper and you'd draw all over it, and then you'd fold it over, and then when you unfolded it, the image would superimpose on the other side. Didn't really work in this case because I just used a marker, but it's supposed to superimpose over on this side, right? We're going to work with that idea a little bit when it comes to inverse functions. So with inverse functions, what we're going to do here is we're going to take this function and first of all, let's replace f of x with a y, okay? I mean, you guys know that. Y means basically the same thing as 2x when we're talking inverse functions, or when we're talking functions, function notation, that sort of thing. So now what I'm going to do is, when we talked about inverse functions in the previous video, remember I mentioned we switch x and y? That's what I'm going to do. I'm going to switch x and y. And then I'll solve for y. So I will subtract the 3 to both sides. X minus 3 equals 2y. And then we divide both sides by a 2. For purposes of illustration, I'm actually going to write this thing in slope-intercept form. So I'm going to have a 1/2 x minus 3 halves equaling y. So your inverse function, written out, it looks like this. So make sure we can read this. It's f inverse of x, right, with that little -1, to show that you've got an inverse function, equals all this stuff, 1/2 x minus 3 halves. You see that okay? Yeah, all right. So that's my inverse right there. So if we were to actually write out steps, I think I would do this. I would say step 1, change f of x to y. Step 2, swap x and y. And then step 3, solve for y. And then finally at step 4, I don't really have a whole lot of room left to write it, but change y to f inverse of x. 4 steps, okay? Bear in mind that step 3 is probably going to be your tough step on some occasions, and in maybe future videos I'll explain why that is. So what I'm going to do here for this problem, let's graph the original function. I'll do the original function in blue, okay? So y equals 2x plus 3 basically. So I've got 3 up here. That's my y-intercept. And it's got a slope of 2, so I'm going to go up 2 to the right 1. I could have also gone down 2 to the left 1. And it looks like this. Now in green, I'm going to graph my inverse now. My y-intercept's at -3/2. What is that, -1.5 about? So right about there. This time I've got a slope of positive 1/2. So I'm going to go up 1 to the right 2, up 1 to the right 2, and so on. So I've got this graph going on. Like that. Okay, now, remember what I talked about with the whole paper thing where if you fold it in half and you unfolded it, the image is supposed to superimpose? If I had paint here, it'd be easier to show, but suppose we could do that with this graph. If I draw a diagonal line through the equation y equals x, okay, y equals x, that's actually the equation here, and if I folded this graph over, my blue line would then superimpose over my green line. Pretty cool, huh? More specifically, let's see, if I had this point here is what, 0, 3? That means 3, 0, there it is, would show up on the reflecting green line, right, for the inverse. And so on. I could try to pick out more. Let's see, if we had a -2, -1, that'd be this point, right? If I drew my graph symmetrically enough, then we would see that -1, -2, -1, -2, there it is, would be this guy. I can write it right. Which makes sense, right? You're changing x and y around. So that's going to create a reflection around the diagonal of y equals x. Pretty cool, huh? All right, thanks for watching.